Good afternoon, everybody. I'm Zhaojiang Fang. To make it easy, you can call me David. I'm from Huawei. And I'm the solution marketing director of the Cloud Core Network product line. It's pretty interesting of the panel. Talk about the 5G oriented. And I think that today is a very good time to talk about cloud, Telco-Cloud once again, given we have already been such a long-term journey for the cloud virtualization, and now we are at this new start point, which is 5G. So long journey for 7 years. Start from 2012. The first NFV white paper that was released in 2012, October, November by ETSI. Start the journey of the NFV, and after 7 years today, everybody talk about cloud or telco cloud. It's about 5G. But if we do some analysis, if we look at the whole of the 7 years, what happens, we can find out that at this moment, about 91% of the carriers actually select full stack solution to set up their cloud, telco cloud. By which actually it can give them the desired agility. And also at this moment, more and more pay more attention on the agility and efficiency. That's what we learned from the past 7 years journey. Look at 5G. 5G brings a lot of new requirements, change. From traffic, 5G, comparing to 4G, 1G more, right? Which means higher throughput, higher performance. And in the future, 5G is not just for the human being, for the entertainment, for the mobile broadband. It also works for whole of the industry, for whole of the society. At this situation, what we see is about 70 to 80% of contents and traffic are going to be created by the edge and consumed by the edge, which means a huge number of the new edge site will be added into 5G network. The 5G network will spread into everywhere to provide low latency and more service capabilities. System architecture from a 3GPP standpoint, change it to service-based architecture, which will give the new demand for the core capability. And network slicing, new functionalities, new features. All those kind of new requirements give a strong need for the telco cloud. From business perspective, from network perspective, more agile. Then deep diving, how we can give the telco cloud more agile. We can see from 4 aspects. Cloud native architecture to make it more reliable, more elastic, more agile with the cloud native architecture redesign. The distributed and heterogeneous infrastructure, as I said, the node will spread into the network everywhere. So that is distributed. On the other hand, from performance perspective, from power consuming perspective, and from cost efficient perspective, CPU, everything to have the general purpose CPU is not going to be the only choice. So we have to consider how to improve the performance with lower cost and lower power consumption. That we call as a heterogeneous infrastructure. End-to-end operation automation. Without automation, cloud benefits will never, we will never take all of the benefit of the cloud. Consider about the SDN, software-defined network, collaboration with the NFV, and also network slicing and edge computing operation automatically. We have to consider that in 5G era. The last one, not the least, but the last one is the ecosystem. 5G for every industry, 5G whole of the society. So collaboration and an open ecosystem will be the key. For the cloud native, in 4G, we talked about how to make it more reliable in cloud. In 5G, we considered decomposition. Vertically decomposition is to separate the traffic load balance and database from the processing layer, which means the software, from a software architecture perspective, there are going to be three separated layers. The service processing layer needs to be designed as a stateless, with which the system reliability is not going to be active standby mode. N-way, we call it N-way, which is the N plus M mode. The whole system, even if whole of the system boards and hardware has failed, if there is just one board still there, the system still needs to run. That's the cloud native stateless design, what it can help. Second one is with the stateless design, since the processing layer is separated from the traffic and data. So, is it, okay, it works. So with that, during scaling, scale out, the traffic reload balancing and database synchronization can happen. So the third one is about the agility. With the cloud native design, stateless design, A/B testing can happen, which means there are going to be two different software versions can run at the same time. If there is a need of new functionalities, you don't have to upgrade whole of the system. Instead, you just have some components run in the system. You can test and try. If you are satisfied with that, then step by step, all of the users and all of the system can be upgraded into the new release gracefully. So that's what we call as a stateless design. The second one is we have to consider about horizontal decomposition. Horizontal decomposition is to separate, is to decompose whole of the functionality into microservice-based. With that, comparing to the monolithic software application, if you need to deploy the monolithic application, it's a huge box. Huge block. You have to upgrade, you have test, you have to run, you have to start up as a whole box. With the microservice, the software release can be developed, can be launched very quickly. We call it the two-pizza rule. A small team develop it, release it, run it. And for testing, 99% of the test effort can be reduced because we only need to test a single small component of the functionality when it is released instead of to test a whole bunch of the system. The interruption of the upgrade, since the system can be upgraded with very small microservices, so there's going to be no interrupt at all. So that is the cloud native from a software design perspective, horizontally, vertically, decompose it as a small pieces. When we talk about microservices, we're not talking about how small the microservice it is, but each microservice itself need to have their independent lifecycle management, need to have the independent upgradable capability. That's what we call as microservice. Microservice also, using microservice can also have some other benefits which fit container very well. Container actually is a very good platform for the microservice. And apparently, container, including Docker, Kubernetes, developing very fast. The trend is, the containerization is going to be, the cloudification of virtualization is going to be replaced by containerization. So the Docker, Kubernetes will be a good replacement for the OpenStack, especially for the 5G, as I said, because 5G system is based upon service-based architecture or microservice capability. So container is the right way to go. Then let's look at the deployment. If we separate the network as a central and edge, the edge, because of the limitation of the resources and also the speed the application needs to spin down, container is the right choice. Container, especially for the bare metal container, is the right choice for the edge node. While for the central part, because it runs a lot of applications and system, even to need to support 3G, 4G, those kind of legacy systems. So a combination of container and virtual machine could be a good choice. But eventually, we believe, container will take the mainstream for 5G. Also, container give a very strong performance improvement because of this lightweight. On the other hand, not just for software or the container, we also have to consider how hardware need to do to reduce the cost per bit and reduce the power consumption for 5G traffic. CPU or general purpose cards, we all know that it's not optimized for the traffic performance. By adding CPU or adding cards is not best choice to support 5G huge amounts of traffic requirements. So how to reduce the cost? Apparently, the heterogeneous acceleration technology needs to be introduced. So especially from the user plane or the edge part, because that take a lot of huge load of the traffic. So by adding like network processor, GPU to have the AR, VR rendering capability, adding the AI chipset to accelerate the AI calculation, or adding FPGA to improve the encryption capability is the best choice. And not just for the speed, not just for the traffic acceleration. By using this kind of accelerated hardware also reduce a lot of cost and power consumption. Here's an example of what we have been doing with the heterogeneous infrastructure. Normally, let's say using general purpose cards, huge stack of the server or disk array or the router need to be added together, put it together as a system to support the particular functionality. With the heterogeneous hardware as a highly integrated box, everything can be combined, adding new hardware acceleration technology into it. We can see the results. From the throughput space, this kind of heterogeneous hardware infrastructure can have 5 times more efficient than the general purpose cards. From the power consumption perspective, half of the power consumption, which means this kind of a solution can really meet 5G traffic requirements and challenge, and also the cost per bit. Besides that, the box itself also is able to support plug and play, which means if the delivery, as I said, it's going to be 100 times of size in the future in 5G era. You deliver into the site, plug a cable, that's done. Everything can be configured. Every hardware acceleration technology and benefit, you can take it. So very easy. So again, when we talk about the infrastructure, we have to consider the balance of the performance, power, and space efficiency. That's what I said about the heterogeneous infrastructure. Automation. Without automation, everything is a dream. So how to realize the automation? At least what we see is the automation to help with the easy to design. From the design point of view, it's very easy because NFV or cloud got a lot of complicated stuff into the system as separated. You have to configure the server, the router, the vSwitch, whatever, right? A lot of complicated work need to be done automatically. From the design perspective, easy to design, agile to deploy, one press button, system run, and reliable to run and reliable to maintain. If there's trouble, adding some intelligence of the system and maintenance operation, you can find out the trouble automatically, easily, quickly, and system can automatically heal. So that's what we need about the automation for cloud and for 5G system. Here listed some numbers you can see with the automation and also with adding the AI capabilities and technology into the system for the troubleshooting, the faults, demarcation, the root cause analysis. It's very easy and works very well. The last one is the ecosystem. So 5G brings a lot of new standards. Push us to adopt the IT mindset, and also adding a lot of revolutionary technologies, and brings the whole of the industry into the system. And carrier had to offer the services to the whole of the society. So to be able to work and adapt to those kind of new challenge and requirements to work together and booming the whole of the industry, working together with the other groups is essential. What we have been doing is we work with the standard group together, we work with the industry group together, and we work with the developer group together to bring new technologies, new standards, and new applications and ecosystem into whole of the 5G system running on the Telco-Cloud. That's pretty much what I have for today. So today here is a summary as a takeaway. If you look at the 5G, today we are talking about Telco-Cloud once again. Facing 5G, we may need to consider about rethink about the cloud native once again, rethink about how to accelerate the hardware and infrastructure for 5G challenging and needs with the heterogeneous infrastructure, and rethink about the automation, how to realize end-to-end automation, including the automatic design, deployment, and maintenance. Thank you very much.